Hi, welcome back to European Autocraft Studios, episode 3. Technically, it should be episode 2, because episode 1, we had the smaller diagrams. We just went through some of the numbers. Episode 2, we started with the nice blown-up diagrams, and episode 3 here today. But we'll still call it episode 3, even though episode 1 really wasn't episode 1. This could be like episode 1.5, or 3, or 2.5. But we'll just call it episode 3, so we'll just stick with the episode 1, 2, and 3. That should work. So today I'm going to cover Terminal 15, how it gets here, and Terminal X. We went over that a little bit, but I want to get a little more in depth. And towards the end, we had some questions about the headlights and how they work. And this is really good because a lot goes on when you turn on the headlight switch, a lot more than you would think. Kind of take it for granted, put the lights on, they come up, everything works. But I'm going to show you how this circuit works by turning the headlights on, and then when you shut them off, why the headlights go down. And if the key is in the off position, you turn the headlights off, the headlights stay up. But the parking lights can stay on. So we'll get to that a little bit later, but first let's start now at Terminal 15. Let's find our ignition switch. Ignition switch. This is where the 15 terminal comes from. We have battery voltage coming in, 30, comes into our ignition switch, goes right through to the radio relay, but Terminal X, that's live with the key in the on position. This is live in the key off position, and then here's our Terminal 15. It's live in both positions. The European cars, we call it position 1, position 2. Position 2 being ignition on, position 1 being the just being like an accessory position, which these really don't have an accessory position. Key in is the accessory position. I know it gets confusing, but we'll cover that later. So here's our 15 out from the ignition switch. It goes right up to this rail, and that's the rail we're going to talk about. So let's go back to part 1, and we'll start here. With the key in the on state, we have power here. This comes down to our ignition coil. So we have battery voltage when the key is turned to the on position, Terminal 15 to turn on the ignition coil. DME does the rest. Terminal 15 here, fuel pump relay. This gets power. So the fuel pump relay turns on. That turns on the, let's see, that turns on, that's our battery voltage comes in. That turns on a supplementary air valve and the fuel pump. But the second relay for this is activated by the DME. That's a whole nother discussion on how that works, but it's a dual relay. Key on turns on some systems, turns on the DME unit. When the DME gets a signal, then it'll turn on the fuel pump. So it's a dual relay. That was still in use for quite a while. Even in the later diagrams, you'll see the same type of relay. Oh, part 2, 15, where are we? Not much going on in part 2 for 15. Everything here is done through the lighting circuit in Terminal 30. Down here, part 3, we got a 15 here. Goes through fuse number 8 in the big fuse relay panel, not the auxiliary panel. What are we powering here? We got the brake light switch, so your brake lights won't work unless the key is in the on position. And our radio relay. Radio relay does a lot more than I thought. So that also gets power with the key on. Let's go here to fuse number 9, 8 amp. This is powering up our emergency flasher switch. Now this is interesting with the turn signals. The turn signals will work with the key on. That's what this is for. But we also have a 30 in here. We'll get to that later, but that supplies power to this so you can have your emergency flashers with the key in the off state. That's for another subject. Let's go back on 15 up here. We have this power horn relay. Horn will only be energized with the key in the on position. But we have 30 power here. See 30? That's here sitting at the relay ready to go. So when you hit the horn button, this comes down from the horn contact ring through the fuse panel. It goes in terminal connector E, comes out connector A and back in connector A to trigger this relay, which only will activate if the key is on, even though there's power here waiting to be activated. So here's the horn. There's the horn there. So the power will only be activated if the key is on. The relay will not turn on, even if you hit the horn button 1,000 times, even 1,001 times. You can try it. Let me know if it works. Let's see, 15 with the key on. We also have ignition. Oh, that's the one going out. My mistake. That's going out. That's what's giving us our 15. G3, not used in this diagram. Okay. Let's go back over here to number 5. What's on number 5 for 15? Nothing, but we do have an X. Now remember what the X is. When the ignition key is turned to the start position, this loses power for load reduction. What turns off? Windshield wipers. This powers the windshield wiper bus inside the switch. So with the wipers going, if you put the key on, the wipers are going. You go to crank the engine. Terminal 50 comes alive. Terminal X turns off. Your wipers will stop wherever they are until the engine is running, or you turn the key back to the start on position. That's 15. What else we have? Not much else going on here. We have ground. Remember we said that there is a ground inside the fuse panel, and that's one thing it's used for. This is the interval wiper relay. That needs a ground. So there is a ground bus inside this fuse relay panel, and that's where it picks up a ground signal. Not everything goes down here. There's some things that are grounded inside the fuse panel. Not much going on here. This is the fresh air blower. We do have an X terminal on that. So this is the blower relay. With the key in the start position, we lose power to the fresh air blower. So your fresh air blower is also going to shut off when you go to the start position. 30, we have power all the time at the cooling fan relay. Our cooling fan, engine cooling fan, also gets power from X that turns on the relay. This relay is grounded all the time. The coil is grounded, so this cooling fan relay will shut off when you go to the crank position as well. Let's see what else we have. This is all 30 radio, a whole nother topic. And the air conditioning system, we have 30. And look, we have X over here as well. The early 944s used a separate air conditioning circuit and everything separate from the heater circuit. So when you put the AC on, it's a whole different entity. You can almost have the heat on and the air conditioning at the same time. This uses X right here. Air conditioner relay, so it looks like the air conditioner is going to shut off when you go to the start position. Let's see, we have 30 here. So the cooling fan relay is all ready with 30 power. There's power waiting there to be triggered. Fresh air blower also comes off of 15 to turn on this relay. So we won't have a fresh air blower and we won't have an AC compressor when you go to the start position. So that's X. Load reduction. A lot of the heavy consumers in the car will turn off when you turn the key to the start position. Terminal 50, which is starter. So let's get into this headlight circuit. We've had some questions about the headlights. Some headlights are either not coming on, or they'll come up and then when you shut them off they do a little dance before they stay down. We'll get into why that could be happening. But we can start off with this circuit. What happens when you put the key, let's say the key is off, but you put the headlights in the parking light position. Parking light position, well, let's start with the off position. Off, as you can see, these wiper contacts are inside the switch. They're broken up here. First position of the light switch, parking light position, are terminal 58. These obviously aren't used. Come here. This one is live in the parking light position or the on position. And the same with these two. This terminal inside, remember, all of these turn at the same time when you put your headlight switch on. This one is closed when the headlight switch is in the off state. So this is the off state. This is closed. That means that we have 30 power on this bus internal, and we have battery voltage coming out all the time to this wiper contact on this rotary disc inside the headlight motor. I'll get into that in a little bit. But right now, with the headlight off, we have power here when the headlight's in the off state. When we go to the parking light position, this wiper contact goes to this terminal, which is nothing, this terminal, which is nothing, but this terminal, which is live, which will become live in the parking lights circuit when the parking lights are on. So what this does is we have 30 power on a 30 bus, which is live all the time. Now we have power going out to the parking light contact. These go off to a different panel. That's not our concern right now. Goes to the parking light contact. This switch here you might all know as your European parking lights. I'll get to that in a little bit as well. But right now, in the parking light position, this comes alive. It comes all the way down here. This is our parking light left. And parking light right. These are rear lights. So all our parking lights are coming on through here, all through different terminals, different connector blocks. Let's see. This one also comes alive with our parking lights on. We have this goes to our fog light switch. That's another explanation for another time why that does that. And up here we come across, this is terminal 58, which is the parking light terminal. I don't know if I covered that last time. Comes across 58, 58, keeps going and going and going. Fuse 12. It splits here. Comes out of connector G, terminal 4, to our illumination potentiometer. That's for our instrument lights. And it goes back to part 5, terminal current track 6. So where is that? Let's go take a look at that. Part 5, current track 6. Heater control assembly. This looks like illumination for our heater control light. So that also gets lit. Our voltmeter gets lit. These are other things that are using our instrument light circuit. From terminal 58. It all stems from terminal 58, parking lights, and that also sends a signal to the dimmer so we can control our dash lights. What else do we have here? Well, that's it for the parking light circuit. Now let's turn our headlights on. We put the key on. We're going to turn our headlights on. What comes alive here? We have, let's see, terminal 4. Let's take a look at this. Black and yellow. Part 4, current track 15, and the letter F will help us find it. So part 4, current track 15, F. Okay, this is our ignition switch. In the on position, that's where we get power to our headlights. Let's see, and it also is supplied by terminal X. I'm sorry, that is terminal X. This is what supplies terminal X and also our headlight switch. So let's go back to the headlight switch. I'll explain why. Where am I? So if the headlights are on and you crank the engine, your headlights will turn off. Another heavier consumer that will take too much power from the starter. So that's also turned off. So this is supplied by X. Conveniently, there's an X terminal there. So we have our key on, engine's running. We turn the headlights on, we have power. Let's see. That is illumination for the headlight switch. This is live all the time. You'll see that when you put the key on, it could be burned out by now. These cars are pretty old, but there is a bulb inside your headlight switch that will light up, and it stays on even when the key is on, but the headlights are off. That's so you can find it in the dark. So let's see. we put the headlights on. We have power going down now from this terminal. Comes out 56. This sends power to our headlights themselves. This is the stock switch that controls the high beam and low beam. This also goes off to the fog light circuit, which I think there's an error here. I'm going to ask you about that later. But this is what will turn on our low beam. Yellow, remember, yellow is low beam. 56B, yellow and black is left side. Solid yellow is the right side. Flip it the other way, we have high beam. This is the white wire. It's white, it's 1.5 millimeter, just like the other ones. That also goes up through the fuses, and we have power to our high beam light. So that's our lights. What else do we have here? These are other 58R. We already went through the parking lights. This no longer has power when the headlights are in the on state. This is no longer connected. You could see the indication of these wiper contacts. This would be out here, not connected. So we no longer have 30 here. But how does it work? How do the headlights go up? Well, here's the motor that drives it. This motor only turns in one direction. It doesn't turn one way to go up and then the other way to go down. It just makes a full cycle. With the help of this contact ring inside, call it a slip ring, contact ring, with the help of this wheel, cut out in certain points, we can turn off this relay at certain points and turn it back on again. So the motor is grounded. This is an indication of a thermal overload switch. So if somebody's sitting on your headlights and you turn them on, it'll eventually shut them off when this overloads, and it'll reset itself. Sort of a built-in circuit breaker. And we have our power wire coming in to the motor through the relay terminals. So this relay is mounted on the headlight motor. There are 4 terminals, 4 wires that also plug into it next to it, the little 4-pin connector. This just indicates that the motor is grounded through the case. That's not a wire that's external. So with the headlight relay in the off state, the motor is grounded, but this relay contact is also grounded. 2 grounds are not going to turn the motor on. We need to get 12 volts here. So if there's no power here, there is power here. This goes off into the fuse relay panel, and it comes down, and we have power on this wiper contact. This contact is also energizing this plate, this disc, slip ring, whatever you want to call it, and sending a signal here, right up to this side of the coil that energizes this relay. This 85 is grounded, along with the motor and everything else. This always stays grounded. So when the headlights go on, we are sending power up, not only to the flasher blocking relay and some other things, we're also sending power to the motor relay. And I just lost that, but that's right here. Okay, comes up and then comes down into here. On the slip ring, we send power out to the relay. Relay energizes, the motor rotates, but it stops because of this. There's a gap. When this gap is here, this gap is on this side. And let me show you over here. In the down position, this terminal here is in the cutout, so there's no power here. This is our 30 power from the headlight switch. When you put the headlight switch on, we have battery voltage here. When the headlight switch is off, we have battery voltage here, but it can't do anything because there's no connection. So the thing just sits there, does nothing, off, waiting to do something. When you turn it on, this is the one that gets energized, and this is the one that goes off to the relay to turn the relay on. In the up state, now we have a way to energize this ring here and here will become energized, but this one is off. So with this one off, there's nothing happening with the headlights in the on position. The motor is sitting there up, separate from the headlights themselves. This is a whole different circuit. So let's go back and look at that here. We're in the off state here, but turn this around. Now our terminal is here on the plate, ready to be activated. The relay is still off because now the headlights are up. The relay is switched off in the up state. When we turn the headlights off, or let's say we just go to parking lights go off. The parking lights stay on, headlights go off, but the motor stays up. The headlights are still up. That's because this contact has not closed. It's only live when the headlight switch is in the off position. So we turned our headlights off because this terminal came off. No more power going down to our washers or anything else, or our headlight switch, so the headlights turn off. Parking lights are still on because we have a contact here. This big wiper contact is live all the time when the headlight switch is in park or headlights on. So back to this. So our headlight motor's not moving. We turn the switch off completely. Our headlight switch contacts are now all in the off state except this one. Now we have battery voltage on this, which is now contacting this and this. These are now connected. Back over here, if these two are connected, now I'm using power from 30 through the headlight switch while it's in the off state to energize our relay. So the motor rotates, the headlights go down, and then this open portion comes back and disconnects this power from our relay. The relay opens and the headlights are in the down position. This has to be sort of precision for it to work right. The cutouts have to be in the right place. We have, if you look at the headlight mechanism, there are springs on it. So if the motor goes a little bit over center, it spring loads the headlights down so they don't vibrate. Same in the up state. They go up and hit a stopper and shuts off at the same time. So the headlights are somewhat preloaded in the up position, and down not so much, but they are preloaded a little bit. They're preloaded up pretty strong so they don't vibrate while you're driving. Anybody that has had body work done to their car and they don't know how to get these headlights adjusted properly, you'll find that while you're driving the headlights are kind of shaking. That's because the stops aren't set right. So the stops have to be set properly, then re-aim your headlights. It's not complicated, but some people just don't know how to do it. So that's the headlight circuit. Now, what would cause this to arbitrarily just, you turn the headlights off and they do a little dance, or you turn them on and they go up and they cycle a couple of times before they finally settle? The only thing that can cause that is this relay being activated. Now, if you have a worn out motor, which is pretty rare, these motors only work so infrequently out of the life of the car. They just don't wear out. And it's such a well-built motor, they just work every time. What we normally find is a little bit of corrosion built up under here. Sometimes a little boot on the motor or around the relay. There's a boot around the relay, and the boot on this connector, this 4-pin connector, can get water in it. These relays take so little current to energize. I wish I could set something up and show you how easy it is to activate one of these relays. They use so little current that water or a little bit of corrosion on these terminals can make this relay activate. And after moving a few times, it just stops. Sometimes they'll keep going for a long time. So normally you find a little corrosion or moisture. If your headlights are acting like that, where they'll go up and down a few times before they stop, you may notice that it happens mostly in wet weather, where this corrosion, instead of being dry, it'll absorb a little bit of moisture and become more conductive. And this will happen more frequently. My suggestion is pull the connector off the headlight motor, pull the relay out, clean everything. If you have compressed air, blow out all the connectors and terminals, connectors, not connectors, and clean them all up really well. You can use some dielectric grease. Don't use silicone grease because the silicone is corrosive. So we want to use a dielectric grease. But clean them really good, blow them out. That should take care of it. If the motor's doing, if that's all clean, then you may have a problem with the headlight switch. You may have a wire that's grounded somewhere. although it wouldn't be grounded. This is 12 volts, so grounding won't do it. These are already grounded, so skip that. But corrosion is generally what causes it. Just a little bit of surface corrosion or moisture will trigger this relay and make it work. Well, that's it for episode 3 with the headlight motor circuit and some of the headlight circuits. There's so much more to it, especially with the fog lights, the flash to pass. If you're experiencing any issues with your headlights, I'd love to know about it. The fog lights in this diagram show that they work with the parking lights on, high beam or low beam. In the US, it's supposed to only work on low beam, but the later cars, I think they did all that. We're going to be looking at the other diagrams anyways. So let me know, try them out, let me know if they work high beam, low beam, if the fog lights will function, and parking lights on these early cars. This is 83, 84, and early 85. So let me know what you have. If you like, I'll get into more of the headlight blocking relay, the dimmer and the flash to pass. We also have the European parking light contact and how that works. So much more to go over if you want. If you think we're done with this, then we'll move on to the later coordinate field diagrams, and we'll get back into the car and start removing the harness, and I can show you more with that. So that's it. Please like, subscribe. Just keep them coming. We're almost at 450 subscribers. Thank you. We really want to make this big, so we need your help. So thanks for watching. We'll see you next week.